Now let's work with a real data set in terms of analyzing the correlation among two variables. We're going to use a new data set that is called examanxiety.sav. You should have this data set on Moodle page, and you could download it and open it up in SPSS. So when you open it up, it looks like this. It has 1, 2, 3, 4, 5 columns. So you probably need to, look into a variable view to know exactly what these variables are: revise, exam, anxiety, gender. So let's move on to the variable view and have a look. So I just make the label display. So code is the participant code, so it's basically an ID for each of the individuals that are being recorded in this data set. So you can see that we have 103 participants here. Revise is the time spent revising. So if we go back, we look at the 4/11/27. So I assume it is a continuous variable that is probably hours, or I'm not sure, sessions that the individual has worked on the exam revision. Then exam is the score of the exam result on a percentage basis. So we know that it will be from 0 to 100. Each of these numbers, 95 is 95%, 40 is 40%. Then anxiety is the exam anxiety. So it's an anxiety level caused by exam. It's scale, it's a continuous data. And here we have all these different numbers. And again, I assume it is a continuous data. I don't know the scale here, but I could easily describe it from the min to the max. I would know the scale. Actually, we could do that. I do it in just 1 minute when we finish the variable view. Then gender, we have the gender variable here. The coding is 1 is male and 2 is female. So no problem. As I promised, I want to have a look at the descriptives for anxiety. We could, of course, have a look at descriptives for everything. As long as it's continuous, it's different for the categorical one, of course. So let's have a descriptive statistics of the continuous variables. So of course I want the min and max. It's by default, so no problem. Variance maybe, yeah. Okay. So let's have a look. All right. So time spent revising from 0 to 98. So it could be a percentage as well, but it could be a hourly based measure. Doesn't matter too much here because we're dealing with the relationship of numbers. As long as the numbers are reported accurately, it should be fine. The mean value is actually much lower than the maximum at around 19.85 at around 20. It's a high standard deviation. You could see that it's quite a large number. It's almost the same as the main number, which means the fluctuation among people in terms of time spent revising is drastic. Performance, well, we have 2 versus 100. So again, a huge difference here. But the mean is sitting in the pass mark in the middle, so that's fine. Exam anxiety, it actually ranged from 0.06 all the way to 97.58. So it might be on a percentage scale, or it's just a scale of 0 to 100. I'm not entirely sure, but again, that's okay. It's perfectly fine for us. Now, what we really need to do is to analyze the correlation, of course, and remember that correlation is pairwise, so we need to pick up the pair we want to analyze against. And to be honest, I think there's different pairs here. First of all, we could analyze between revised time and exam performance, and I have the assumption that there's some correlation here. These two are related or influencing each other somehow. My guess would be that if you spend more time revising, you will have a higher mark, but that's my guess at the moment. So a positive kind of correlation here. Of course, there's the possibility of relationship between anxiety level and exam as well. If you're more anxious about exam, maybe you didn't prepare that well. So there might be a negative correlation among these two. But of course, the revised time might have a correlation with an anxiety level as well. If you revise more, your anxiety level should reduce. Well, that's my assumption. But we're gonna test it. We test the first pair here because for demonstration purpose. All the other pairs are very similar in terms of the testing process. So we just assume that there's a correlation between revised time and exam performance. Of course, we talk about the correlation in terms of visual effect of the correlation. We talk about actually observing the scatter plot. So can we actually draw the scatter plot and have a visual kind of clue before we actually run the comparison, run the correlation test? Yes, absolutely. So let's do that first. My assumption would be, okay, revise will have a positive, revised time will have a positive impact on the exam performance. So here our independent variable is revise, our dependent variable is exam. So if I want to draw a scatter plot, I go to the graphs and legacy dialogues. Well, you could build your diagram from scratch. I don't mind, but here we just use already made scatter plot command. So it's a simple scatter around two series of data. So I just click on define, and the x-axis is our independent variable and y-axis is our dependent variable. You have to be very clear about that. Well, if you mix it up, the actual shape of the diagram will change, of course, and also it will make it really difficult for you to interpret the result. Can you interpret the result as the exam performance has a impact on revision? That's counterintuitive because revision happens first, then you perform in the exam. So make sure that you understand the dependent variable here. So our dependent variable y-axis is the exam performance, and our x-axis, that's its independent variable, is actually the time spent doing revision. And that's it to draw a scatter plot. You don't need, well, of course, if you want the title, you could input the title, or if you want to change something here, but I otherwise not to leave it as default. Click OK, then we should have the scatter plot among these two series of data. Okay, that's a scatter plot here. Right, you can see that it's rather random or not so clear in terms of pattern when there's low revision time. But when your revision time start to grow, we could see that it's actually helps in terms of lifting the exam performance. So of course, we could draw a correlation line across all these individual scattered dots. And to do that, you just need to double click. Well, you could do it in a function, but it's easier to just double click on the scatter plot, and it'll be it will be singled out. It has a new window pops up, and that is the diagram window. And on the diagram window, you will have the choice to add a eyes here, to add a fit line through the total observation. So be careful, you're using this add a fit line instead of this command here, add a reference line. Reference line is a perfect 45-degree angle against both the y-axis and x-axis. Instead, we're adding a fit line here. So if I click on it, well, it did a good job. I don't need to see the report here. It's actually give you a equation as well. It reports this equation here. That's the parameters, if you like. That's the slope of this line. It's sloped at 0.57, and we know that it's the tangent of the line at 0.57. And the starting point, this intercept point, is at 45.32. So if I close it down, the line will still be here. And we can see that it's actually a positive relation. Every time the time spent revising increase, right? If we increase around along the x-axis, the value will increase as well for the y-axis. So that reported a positive correlation based on the scatter plot. But will that be the case if we actually run the correlation function or test? Well, let's find out. We just close the result window. Now the correlation is under Analyze, Correlate, and Bivariate. It basically means it's comparing against a pair. There are other things like partial distances, but here we're using the bivariate correlation. So if you click on it, then it asks you to input both the pair of those. So it does not distinguish between independent and dependent, because it basically reports both ways. Well, you will see what's both ways. It's repeat. It's basically A against B, then B against A again. It's the same number. It's just the way I report it. So here it has the coefficients Pearson, Kendall, or Spearman. So before we go ahead, we need to come back to talk about this. So Pearson for the parameter is when you have a parametric variable. So parametric variable is basically saying that your dependent variable is normally distributed. Then you have a Pearson coefficient. Then if your dependent variable is non-parametric, then that's a non-normal distribution, then you should choose a Spearman. So essentially, you need to check your dependent variable as well in terms of distribution. But majority of the time, Pearson and Spearman does not report a drastic difference if it's not a specific type of distribution. If, in fact, it should reassemble, as long as, in fact, it should reassemble a somehow normal distribution, it should be fine. But strictly speaking, you should check the distribution first. When we talk about distribution during session 4, of course, session 3 as well, it's basically you need to observe the histogram of these variables. At the moment, I just go ahead with Pearson, assuming that the exam performance is normally distributed. So if I click, well, we could check that. We could actually check that. It's not going to be a difficult task anyways. So let's actually check that. Let's not to be lazy. It's not perfect, but it's all right. I think it's still bell-shaped. Well, if you have to say something, it's kind of missing a little bit on the right-hand side in terms of its tail, but I think it's all right. So yeah, Pearson it is. So let's go back to correlation, correlate. And what are the two variables we want? Here we go. Pearson it is. No need to change any of these, but if you do want to click on it and see what's going on, feel free to do that. Did I accidentally uncheck that? Okay, so click OK, and that is our correlation table. Correlation table of the two variables. One is the revision, time span revising, and another one is the performance in the exam. Okay, so time spent revising exam performance. It has a, well, let's look at this number first, 0.397. That is the actual parameter or coefficient of correlation. So that is saying every 1 unit movement in time spent revising will impact of a positive 0.397 unit of movement in the exam performance. And that 2 stars is the significant level of this influence. So you have the strength of this correlation, then you have whether this correlation is indeed significant. That is, whether we're really sure about this correlation. And here 0.000 is the very high significant level. So we're really sure there's a correlation, and that strength is this. The second half of the table is exactly the same, but it's comparing the exam performance is here, then the time span is here. Then you can see those 1 and 1 that I've been talking about that appears diagonally in the correlation table.